Polynomials will show up in pretty much every segment in this playlist and future playlists, so it's important that you understand what they are. So first, we can start off with polynomials in one variable. Polynomials in one variable are pretty much just expressions that consist of terms in the form ax to the power of n, where you'd say that n is some integer which is greater than or equal to 0, and a has to be a real number. And if you don't know what real numbers are, in our previous video we went over them. But to recall, they're just any number you could think of that exists on the number line. Now another way to say that n is some integer which is greater than or equal to 0 is to say it's a non-negative integer. Now we're going to call a our coefficient of our term x to the power of n, as it stands beside it. Now for the degrees in polynomials with one variable, the largest exponent in the polynomial is going to be the degree. So for example here, our degree is 4 since the largest exponent is 4, and our degree in this case is 1 since our largest exponent is 1. 5x to the power of 1 is just 5x. Now let's iron on the last example. With -8 as a constant term, has to say it appears by itself, we need to remember that polynomials come in this form, and so -8 can still qualify as a polynomial, since we can rewrite it as -8 times x to the power of 0. And we should know that every non-zero term to the power of 0 is 1. So this is the same as saying -8 times 1, which is just -8. And so it's still a polynomial. So here's some examples of non-polynomial expressions. We have 4x to the power of 6 plus 15x to the power of -4 plus 7. And now -4 is highlighted here since it is not a non-negative integer. And remember, for our definition of a polynomial, n needs to be a non-negative integer. And so this will not qualify as a polynomial. Same for this case. We can rewrite this as 5 times x to the power of a half. And as we know, a half is not even an integer. Since remember, the set of integers are whole numbers that do not appear as fractions, which are either negative or positive. And obviously, a half appears as a fraction. Now, if you've watched our previous videos, we would call this a rational exponent. Now let's take a quick look at polynomials with two variables. And before we were looking at them with only one variable. Two variable polynomials are expressions consisting in the form ax to the power of n times y to the power of m. And they need to satisfy the same memberships for one variable polynomials. N and m must be real numbers. And a has to be a non-negative integer. Now, for two variables, the degree of each term in the polynomial is the sum of the exponents in each term, and the degree of the polynomial is the largest such sum. So in this case, the degree is 15, since the largest sum here is 15, 3 plus 12. And same for this, the largest sum we can make is 4. And remember that in these kinds of polynomials, not every term has to have an x and a y with it. And as we see here, the degree might come with a term which only has an x or only has a y. Next, we need to get some key terms out of the way. A monomial is a polynomial that consists of exactly one term. So for example, 7x to the power of 3. And this is one term. And a binomial is a polynomial with two terms. So for example, 3x squared plus 5. And as you can probably tell, a trinomial is a polynomial that consists of three terms. And for an example, we have x squared plus 4x plus 4. And this consists of three terms. X squared is one term, 4x squared is another term, and 4 is its own term, which we'll call a constant. And same in this case, 5 is a constant. And now again, recall that numbers like 7, 3, and 4 are all coefficients. And this sequence can generalize to polynomials with arbitrarily many terms. So we might have a 5-term polynomial, which is the same thing. We just have a polynomial, but now with 5 terms instead of 3. Now let's introduce the distributive law for multiplication over addition, which we're going to use for the rest of this segment. So what the law is telling us is that if we have a multiplied by the quantity of the sum of b, c, then that's the same as the sum of b and c, where we multiply each term by a. So as in the name, distributive law, we're distributing a onto b and c. Now let's try to crack some examples where we're dealing with sums and differences using this distributive law. And in the first one, we're going to be adding two polynomials, and then the second one, we're going to be subtracting two polynomials. So to start for a, we're going to be adding the two polynomials together. So to add polynomials, all we're really doing is combining like terms. And to combine like terms, we're just looking for the terms in the polynomials which share the same exponents. So in this case, 13x squared and -10x squared both have the exponent of 2, and so we're going to add or subtract the coefficients of those terms. So to start, we see no other term in the other polynomial has a power of 5, so we can write 6x to the power of 5 on its own. And now, as I said previously, -10x squared and 13x squared have the same exponent, and so we're going to add them together. Now again, we can see that x and -9x both have an exponent of 1, and so we're going to add the coefficients together, which are 1 and -9. Now lastly, we see that negative 45 and plus 4 both are constants, and so they're going to have in common an exponent of 0. Since we can rewrite them both as 4x to the power of 0 and negative 45x to the power of 0. So when simplified, we get 6x to the power of 5 plus 3x to the power of 2 minus 8x minus 41. Now for b in doing subtraction, we're going to want to do is distribute the minus sign through the second polynomial. And so what that means is that every term in the polynomial, we're going to flip the sign of. So 5x to the power of 3 becomes negative 5x to the power of 3. Negative 9x squared becomes plus 9x squared, or just 9x squared. And then x becomes negative x, and negative 3 becomes 3. And again, this is just using our distributive law, where we're treating a as a negative 1. And so we're going to keep x squared plus x plus 1 the same for now. And it'll look like this. Negative 5x to the power of 3 plus 9x squared minus x plus 3. Now, just like in the second example, we're going to look for terms which share the same exponent, and then we're going to add or subtract their coefficients. So x squared and 9x squared both have an exponent of 2, and so we're going to add their coefficients. So now a good way to lay this out, and we see that no other term has an exponent of 3, and so we can just write that to start. Now our second largest exponent is 2, and so we can see that x squared and plus 9x squared both have in common the power of 2, and so we can add the coefficients together. And again, we can see that x and negative x both have a common exponent of 1, so we can add those together. And again, lastly, we have two constants, namely 1 and 3, and so we can add these together too. Now when we simplify, again, we can keep that the same, so it's 5x to the power of 3 plus 10x squared plus 1 minus 1 is 0, so that will be 0x plus 4. And now in this case, we can further simplify since 0x is just 0, and we can discard that from the polynomial expression. And that should be our answer. On to multiplying polynomials, where for a, we have 4x to the power of 2 distributed over this trinomial, and then in b, we're going to look at using the FOIL method to distribute the binomial. Now for a, this is nothing more than a quick application of the distributive law, so we're going to get 4x to the power of 4 minus 24x to the power of 3 plus 8x squared. Now if you feel you've struggled with dealing with multiplying out powers, then I suggest you watch my previous videos on exponents. So for b, we're going to use the FOIL method. Now remember that the FOIL method is only going to work when we're multiplying two binomials. So if either of these are not binomials, then the FOIL method will not work. So remember, FOIL is just an acronym for the first term, outer term, inner term, and last term. So the first term is the multiplication between 3x squared and x squared. So the first terms in both binomials. And so that's going to be just 3x cubed. And now for the outer term, it's the outer term of both binomials, so 3x squared, multiplied by negative 10, and that's going to be negative 30x squared. Now for the inner terms, we're looking for the inner terms of the binomials, which is 5 and x. So 5 times x is just 5x. And the last terms, as you can tell, is just 5 times negative 10, which is negative 50. We're nearing the end of this video, so I want to work on a set of examples for some special products that I'll give the formulas for afterwards. Now if you want to pause the video and attempt these on your own, feel free to. For the first one, we can use the FOIL method again, so we're looking at the inner term, which is 3x times 3x, which is 9x squared. Now we're looking at our outer term, so it's 3x times negative 5, which is negative 15x. And our inner term, which is 5 times 3x, which is 15x. And then our last terms, which is 5 times negative 5, which is negative 25. Now, since we have two terms which are the same with opposite signs, we can cancel them out. So we'll just get 9x to the power of 2 minus 25. Now, if you watched our previous videos on exponentiation, remember that the definition is just a to the power of n is just a multiplied by itself n amount of times. So in this case, a is what's inside the brackets, 2x plus 6, multiplied by itself twice. So this can be rewritten as 2x multiplied by itself twice. So 2x times 2x is 4x squared. 2x times 6 is 12x. 6 times 2x is also 12x. And then 6 times 6 is 36. Now we can simplify. 12x plus 12x is the same as 2 times 12x, so that's 24x. And then 36, which is our constant, stays the same. Now, just like the last example, we're going to be using our definition of exponentiation, so we'll rewrite this as 1 minus 7x times 1 minus 7x. Now again, apply the FOIL method. So 1 times 1 is 1. 1 times negative 7x is negative 7x. Negative 7x times 1 is negative 7x. And then negative 7x times negative 7x is plus 49x squared. And remember before, we would like to write the term with the largest exponent on the left-hand side. And so we'll do 49x squared minus 14x plus 1. And that's our answer. Now, each example we just did corresponds to a special type of product. So in this case, we can see that we have two binomials where we have the sum of a and b, and then the difference of a and b, and that's the same as a squared minus b squared. And for our second example, where we have in the brackets the sum of a and b to the power of 2, that's the same as a squared plus 2ab plus b squared. And then if it's the difference, then that's a squared minus 2ab plus b squared. Now to end, these are some common mistakes I see often made when dealing with multiplying out binomials. So if we have a plus b squared, that's not the same as a squared plus b squared. And if it's the difference of a and b, then we wouldn't either say that it's a squared minus b squared. Now, in the next video, we're going to be looking at these polynomials where we're factoring them.